I am Mark Johnston, and I do videos on STEM education and a lot of videos on VEX Code VR. VEX Code VR computer science activities and resources have been updated. VEX has been amazing in offering this really cool tool for free. So I'm excited to bring you this new installment of some new activities. And so I'm going to be showing you guys the shape tracer today, specifically covering triangles. So let's go ahead and get into it. And so we have some new activities. The activities I'm going to be working on today are found when you click activities on VEX Code VR. Here we have the computer science VEX Code VR activities and resources. And there's some good resources here also for teachers. And you can see already we have color counting algorithms is new. Counting lines is new. We have down here sensing colors, that's new. And then we've got tracing polygons, tracing triangles, and tracing unique shapes. So let's go ahead and look at the tracing triangles. And you can see here it opens up a Google Doc, which is really great. For those of you teachers, you can always make a copy and then modify it yourself. And I highly recommend doing that if you are a teacher, modifying these levels to add your own twist on it. Wanting to make sure you have an appropriate challenge for your students and that they're not just able to go out and copy their own thing. I would add your own twist to these, okay? So you can see here that the level 1 is with your selected triangle, draw around the perimeter using the pen on the VR robot. And that's all I'm going to focus on in this video is the level 1 challenge to kind of get you through that. Level 2 and level 3 obviously for a little bit more advanced users. And if you're at like the high school level, you can even go higher than level 3 and really get them to do some interesting stuff. All right, so here we have, when I click on playground up here, I can go down and select these different playgrounds. I'm on the shape tracer playground is what this is. And you'll notice that if you have been using VEX VR for a while before here, January 2021, then you'll see there's a new button here. If you're new to VEX, they've done some amazing improvements. It started out fairly simple, and they've done some real amazing, great improvements. I love it. All right, so if you click on this button right here, you can see that I can choose my starting location. And so I have starting location A, B, C, and then all the way through I. I am going to focus on A, B, and C right now. I'm going to go ahead and start at position A to begin with. And if I click play, this program that you can kind of see, through back here, peeking through here, is already set up for these triangles. So you can see I traced triangle 1 there. I'm going to go ahead and switch to B here and push play. And just like that, it's like magic. The same program that I have set up will run location B. I'll go ahead and change to location C, and it pops my robot over there, and I'll push play, and I'm already on location C, just like that. All right, now let's go ahead and get into the code that I did for this. I'm going to take you step by step. And so in order to do that, I'm going to go to vr.vex.com, and I'm going to name it Tracer, because I'm not going to just do triangles. I'm going to end up doing all of the shapes. But for this video, just the triangles. All right, first thing that I know that I want to do is drop my pen down. And so I'm going to go under the looks category here. And of course, I could just scroll down right here, but I'll click on looks and it takes me right to the looks. And then I'm going to drop the robot pen. So robot pen down. And the way that I do this and the way that I figured this out was quite a bit of trial and error. There may be a more efficient way to do it. I'm just going to share with you, be open, honest, transparent about the way that I've done it. And so I'll click on Playground. You'll notice here I can expand to get a little bit bigger view here. And the Playground, every time you open it, does have to load. And so what I recommend for students who may be on a Chromebook or a slower device, rather than closing this Playground once you have it open, clicking the little hide button will get it kind of out of the way. And then when you show, it won't have to reload that Playground each time. Just a pro tip for you, make your life a little bit easier. And so the first thing that I know that I want to figure out is it looks like I have a right triangle here. And I'm going to get a better view of it and just kind of move around here. So I clicked on this little view button. And I noticed that it's definitely a right triangle. Okay, I have this grid here so I can see that. So I know I have a 90-degree turn here. So that's helpful. And then if it is a right triangle, and if these two distances, these two legs are the same length, then that makes it real easy for me to figure out my angles, knowing that triangles, the interior angles should all add up to 180 degrees. So then I just have to do some simple math. 180 minus the 90-degree angle here leaves me with 90, which then if I divide by the two remaining angles, gives me 45-degree angles. I'm going to drive the robot forward and then turn. Now I don't want to turn 45. I want to turn all the way around less 45. Right? So think about it that way. My robot is going straight up, and then instead of just turning 45, I want it to turn like 180 degrees, but not quite 180 degrees, 45 degrees less than 180 degrees. And so I'm actually going to use some math functions and operators in here to make my life a little bit easier as far as just doing some basic arithmetic. Why should I do that if I can just get the program to do it for me? Right. So the trial and error part of this was figuring out how far the robot has to drive, what the actual distance of this leg of the triangle is. And like I said, I just did trial and error. So if I drove forward like 400 first, and so you'll notice I'm up here in the drivetrain tab, and I selected drive forward, and then I changed the amount to 400 millimeters. I'll reset and then press play, and I realized, I didn't quite get there. So it took me a couple tries, but I figured out that first leg is actually 500 millimeters. And then I even just duplicated, so I can right click on this block and say duplicate and change it to say like reverse, right? And then I'll refresh, I'll push play, change my angle, really get in there and look, and yeah, it went the whole distance. Perfect. So the next thing I wanted to do is figure out, is that bottom leg actually 500? And so the way that I'm going to do that is I will reverse for 500 here. Then I'm going to turn right for 90 degrees and then drive forward for 500. And then the reason I'm putting a reverse in there is just to get the robot out of the way so I can see if it in fact drove the full length of that line. All right, so here it goes all the way to the 500 and perfect. Okay, so that tells me for sure that both of those legs are 500. And so now I know what those two angles are. All right, so what I'm going to do is I'm going to have it drive forward for 500. I'm going to have it turn right. And remember, I want to do this math. So I'm going to find the operator. These are the green ones. I'm going to use the subtraction operator. And remember, if I turned 180 degrees, it'd be all the way around. But I want to go all the way around less 45 degrees. All right, so that's that outside angle. So I'll go ahead and restart, press play, and let's see if I get my angle correct. And sure enough, there it is, pointing exactly in the right direction. Now, the tricky part here is that I am going to need to do a little bit more math. Looks like we got some 8th grade math coming in here with the Pythagorean theorem. Pythagoras is my homie. All right. What an amazing dude back in the day, figuring out that you can use the square of this side plus the square of that side will equal the square of that side. Crazy, crazy. All right. Another way to say it is that the square root of this, of the square of this side plus the square of that side is equal to that distance. All right. So I'm going to set that up using my math operators here. So I know I want to drive forward, but I don't know how far I want to drive forward. If I drove 500, it wouldn't quite make it there, right? Because if the distance here is 500 and the distance here is 500, so leg A and leg B, leg C, which is what we call the hypotenuse, would be more than 500. So if I reset this and push play, I'm probably going to end up around here, I'm thinking. So there we go. And yeah. So I need to figure out what that complete distance is. Now I could do some trial and error and just keep on tweaking that number. Try 550, 575, 580, and then that would be could be a nightmare. Taking me forever to figure that out. Well, when I know the Pythagorean theorem, I can figure out exactly the distance that it needs to go. So I'm going to find some a little bit more advanced operators here, a little math here, and you'll notice this like rounded shape fits in the rounded shape here, and I have this little drop down for all these really cool math. Some of these are like trigonometry. And so what I'm going to do is I'm going to use square root. It's SQRT, square root. And I'm going to drag that. So I want the square root of the square of this side plus the square of that side. So I'm going to get the plus. All right. And this square, there is no squared in here. So we're just going to do the multiplier. So I'll do that. This little asterisk, multiply. So I'm going to do 500 times 500. That's the same as 500 squared. And look, I can right click in there and say duplicate. And I got 500 times 500. Okay, so look at that. I got 500 times 500, which is 500 squared, plus 500 squared. And the square root of that sum is the distance of my hypotenuse. So that should take me the full distance. Now the cool thing here is that I can duplicate this angle because I know that that other angle down there is going to be the same as this angle. So those two angles are the same. So I'll refresh and say play. And let's see. Drum roll, please. It hit it. Perfect. And it looks like it's pointed exactly the direction it needs to be. And I know that distance is 500. So I don't need this. I can say drive forward for 500. And then tell you what, I'm going to go here. And I'm going to say turn right for 360. I'm going to do a little victory spin there at the end. We'll reset and play. All right. Yeah. All right. That's all there is to it, people, for our right triangle. And so we have our first triangle done. If I go ahead and click B, so I'm going to change my location to B, and I'm going to do this triangle. And you'll have to forgive me. I'm not a math teacher. I'm not I don't teach geometry. So the name of this triangle eludes me. I'm pretty sure that each of those angles are exactly the same. And again, I do know that a triangle, all the angles equal 180 when you add them all together. And these all look about the same. They all look about the same angle, I'm pretty sure. So I think I'm going to take 180 degrees divided by 3. So if I take 180 degrees divided by 3, so I'm going to use this exact same code here. I'm going to drive forward for 500. I think it's 500. So I'm just going to, again, use trial and error here. I'm going to push play and see if it hits it exactly. It does. So that's 500. So notice how I'm overlaying that triangle. I can get a comparison going of that triangle and that triangle. All right, so I need to change this angle, and I'm not going to need this math here. So I'm going to get rid of that. So I'm going to say drive forward for 500, and then I'm going to use the division operator. So I'll go down here. It's this little slash guy, and I'll say 180 divided by 3. Now, there's something wrong with that. See if you can figure out what's wrong with that. Remember what we had to do over here. We didn't turn 45 degrees. We actually turned 180 minus 45. So what's going to happen here? Let's click play. So I am going to drive that 1/3. Notice it turned. That's 1/3 of 180. So it's 180 divided by 3. But remember what happens is I'm doing that outside angle. So I need to actually go 180 degrees less whatever that angle is, 180 divided by 3. So I'm going to add another layer of math here and say, grab this subtraction. And I'm going to say, again, I need to go 180 minus whatever this is. So now I have a little bit more complex thing going on here. I have 180 degrees minus 180 degrees divided by 3. All right. There's other ways we could do that mathematically. I'm doing it this way to illustrate my thought process. All right. So you could probably multiply 180 by a factor, but this is the way I'm going to do it. So let's go ahead and reset and play. And notice, boom, I am looking exactly in the direction that I need to be looking. And I think all the sides are the same. They're probably all 500. So I could do this. I could duplicate that. And then I could duplicate this, because I know I need to drive 500, turn, drive 500, turn, drive 500. And I don't need to turn there at the end. So, but I just wanted to show you that it's all 3. It's doing the same thing 3 times. Look at that. Yes. Yes. And that's it. Boom. All right. Now, I can make this a little bit nicer, because anytime I'm doing the same thing over and over, I could use repeat. So I go under control, and then I'm going to grab this repeat here. Actually, I'm going to set it over to the side for a second. I'm going to get rid of all this duplicated stuff. I don't need that. I'm going to get rid of that. And then I'm going to put this repeat over and put those drive forward and then turn. And I'm going to have it repeat just 3 times. So I'm going to drive forward for 500, turn, drive forward for 500, turn, drive forward for 500, turn. Because it's going to repeat it 3 times. So I'm going to go ahead and reset and push play. Drive forward, and if I move my thing down, I can see it's flashing in green. I can see where it is and what it's doing. And sure enough, there you go. All right, that's it for the middle triangle. Pretty good, right? Let's take a look at triangle C right here. It's a little bit more complicated, but we'll get it. Disclosure here is a little bit more complex. Now, I wasn't quite sure what Vex was thinking as far as how I would figure out what these different angles are. So I'm just going to show you how I did it. The first thing I did, again, had to do with kind of trial and error. It was figuring out the distance of that first leg A, and then I'm calling this one down here B, and this one C. And so I can get rid of this repeat. I'm just going to have it drive forward to draw the line, and then I'm going to have it drive backward to get it out of the way so I can see it. I'm pretty sure it's not 500, it just looks a lot shorter than that. So I'm going to start off with 300, and I'll have it reverse for 300 just to get out of the way. We go ahead and reset and play. Oh, got to change this to reverse, or else it was trying to go 600. There we go. 300 forward and back. All right, so each one of these little squares, I believe, is 25. So 300, 1, 2, 3, 4. So it's probably 400, or maybe even just shy of 400, because it looks like that tip goes, or maybe a little more than 4. I don't know. We'll see. So I'm going to go ahead and pull this out of the way. Let's go 400 and see what it does. Reset and go. Oh, too much. So I don't think those are actually, those are not 25. I think maybe they're 10. Oops. Okay. So if, or there might even be 20. So I think they're 20 actually. So if I was at 300 and there was 4 more, then that would be 380. So 380. Let's see, refresh, go. Let's take a different view. Yeah, I'm pretty sure it's 380. It looks pretty good. Keep in mind these lines are going to a point, a tip, and the marker that is being illustrated here on this robot is, you know, like a square marker. Okay, and so I'm going to use 380. Now, for this angle, I just had to kind of do the same thing and figure it out. So I'm going to say drive, turn right 4. And then I'm just going to have it drive forward for a little bit to get it out of the way. See if I made that angle. It looks like it's definitely, I'm saying 90 plus 45. So the exterior, I'm just curious about what this outside angle is. The outside angle, of course, is 180 minus whatever that inside angle is. I'm thinking that inside angle looks like it's about 30 degrees, because it doesn't look like it looks like tighter than 45. 45 looks like it would be out here. So I'm going to say 30 degrees. So 80 minus 30 is 150, right? So I'm going to turn for 150 degrees. I think that's actually what it was. But I think I first guessed like 25 degrees and I was wrong. Yeah, so it's a 30 degree interior angle there. And then of course the exterior, because I have to turn all the way around, is 180 minus the 30. Okay. All right. I have 2 pieces of information. Now, trigonometry, which is the area of math that's focused on triangles, trigonometry, and it's like geometry, but for triangles. And trigonometry tells us that if we have 3 pieces of information for a triangle, we can get all the other pieces of information. Because I think if you have 1 angle and 2 other pieces of information, you can get all the other stuff. Again, I'm not a math teacher. If you are a math teacher, if you want to put some information in the comments down below, I would really greatly appreciate your help with that. All right. But I'm focused more on the programming here. You can definitely go into the math more. I'll stay in my lane. I'll let you guys do the math. All right. Do the math teaching. All right. So, again, I want to kind of just trial and error my way through getting the length of this. So I'm going to have it drive forward for, say, like 700. And again, I want it to turn. I don't know what the angle is yet. So I'm just going to have it say turn right for 90 and then drive forward for 200. Again, it's just to get that robot out of the way so I can see if I actually made my target here. So right here, and then 700 looks like it might not quite enough. So I'm going to say 740. Looks like it's probably about 740. 740. Now the cool thing about this is once I get this, I'm going to show you, I don't think it's cheating if I'm using a calculator that actually, a triangle calculator. Okay, I'm pretty sure I hit it. It looks like it's just shy of it, but I think 740 for all intents and purposes is going to work just fine. So I have all the pieces of information that I need. I have a 30-degree angle, which, the interior angle is 30, so I'm turning 150 to make that. So a 30-degree angle and a leg that is 380 and a leg that is 740. So a quick Google search finds calculator.net, and calculator.net has a triangle calculator. So check this out. If I put my 380 length of side, they're calling it side B here, it's fine. And then up here, if I do my 30-degree angle, and then right here I do my 740 length, it's going to fill in these other pieces of information. Watch this. Calculate. Haha. So it actually gives me all this information. So this is great. But I'm going to look at this view right here and notice that here 740, the angle down here, 24.815. Very accurate. 24.815. I'm actually going to use that. I'm going to do 180 minus 24.815. And I'm not even going to use a calculator. I'm going to use the operator. And then look at this, 452.71. I'm even going to do that, 452.71. So let me remember that, 24.815, 24.815, 24.815. I'm going to find an operator here, the subtraction. 180 minus 24.815, I think. All right, let's go ahead and refresh and try that and make sure that we are on the right track here. And is it going to point in the right direction? Yes. Look at that. So close. It might be a little bit off, but I think we might be saved by the thickness of the black line here. So that might be saving us for a slight error. It might be slight error correction. And then I want to drive 452.71. I bet I can copy and paste that. Here we go. Go over here. I'll refresh. And right here, I'm going to paste it. Yep, 452.71. Reset and go. And it's exciting. Is it going to do it? Is it going to do it? Do it. Yes! Victory! I have done all 3 triangles. And so I'm now going to show you how, at the beginning, how did I do this? Where, look at this. If I choose any A, B, or C, and I push play, it runs it. How is that? It's the same exact code. Maybe I should leave that as a mystery. How about you tell me in the comments if you think you know how I did that, where no matter which one I select, I can just push play. I don't have to have a different program. It's all in the same program. You might be able to see a little bit up in there, like that's giving you a kind of a clue as to how I'm doing it. Even way up there, like what's that equals 540? That's weird, huh? Okay. Look at that. And I go to A, I can push play and it runs it. I really hope that you enjoyed this video. In the next one, I'll be doing the polygons down below. Looks pretty cool. Looks like we got a pentagon, a hexagon, and an octagon. And so I really look forward to seeing you in the next video. Please feel free to let me know if you have any questions or suggestions. You can email me, mark@westrobotics.org. You can join our Facebook group. There is a link. I'll put a link in the description. I'll put a link to calculator.net in the description. I'll put a link to everything I can think of in the description. We also have a Discord server where we have a few people in there that like to talk about all things VEX Code and specifically VEX Code VR. So I really look forward to you guys joining our community. If you really liked this, if you think you'll be using anything like this again in the future, please give me a subscribe, like the video, and thank you so much, and have a good one.